Welcome back. You know, I saved this lesson 1.4, to be its own unit, its own module, because it's such an important lesson. So when we finished continuity, which was lesson 1.3, I wanted to stop and have a test and just make sure that we were all on the same page and we'd all mastered what we needed to before moving on, because this final lesson in chapter 1 is going to lay the groundwork and lead right into the calculus stuff we're going to do in chapter 2. So that's why we're doing section 1.4 on its own. We're going to talk about the idea of rate of change. There are different kinds of rate of change. Today we're going to focus on the average rate of change. There we go. And this is what's called an essential building block for calculus. Everything is built on understanding these different kinds of rates of change. So today, just average rate of change. So in general, the average rate of change of a function over an interval is the amount of change divided by the length of the interval. Okay, the amount of change divided by the length of the interval. The way we write that is like this: f of b minus f of a over b minus a. Okay, this is the amount of change on the top, which is f of a higher number minus f of a lower number divided by the interval on the bottom. This is also similar to slope. Okay, it can be thought of the slope of a secant line. So y2 minus y1 over x2 minus x1. These two have similarities. They help us determine the same thing. F of b is always the larger number compared to a. All right, so that's important that b is larger on the interval. So we might have an interval, and we might have a and b, and then on your function, you might have the y values, and this is f of a, and that is f of b on the function. Okay, so a and b are on the x-axis. F of a and f of b are the y values that are on the curve itself. So find the average rate of change along the parabola curve, f of x equals 2x squared minus 3x plus 7, over the interval starting at -2 to 4. So we've got -2 and 4. -2 is your A, 4 is your B. Now let's plug those values in to this parabola. If we plug -2 into the parabola, that would be 2 times -2 squared minus 3 times -2 plus 7. That works out to be 2 times 4 plus 6 plus 7, or 8 plus 13, or 21. So we've got 21 as our value. Now if we wanted to find, so f of -2 turned out to be 21. Okay, let's find the value of f of b. So we're going to plug 4 into the equation. So 2 times 4 squared minus 3 times 4 plus 7. That's 2 times 16 minus 12 plus 7. That's 32 minus 12 plus 7. That's 20 plus 7, or 27. So we have 27, and that equals f of 4. And there's a parabola that connects those two. All right, so there's some kind of parabola coming through, connecting those two. All right, but we want the average rate of change. So the average rate of change will be f of 4 minus f of negative 2 over 4 minus negative 2. Well, we already figured out f of 4, that's 27. We figured out f of negative 2, that was 21. So we have 27 over minus 21 over, now we've got a double negative, 6. So this turns out to be 6 over 6, and so the answer to the average rate of change is 1. You can also do average rates of change off of a table. So if we're going from 3 to 9, this is our interval. Okay, when you use brackets like that, that means we're talking about an interval. 3 is the A and 9 is the B. And so if we want to find the average rate of change, I'm going to call it ROC just to abbreviate. That would be f of 9, the larger one, minus f of 3 over 9 minus 3. So f of 9, according to the table, is 10. Minus f of 3 is 5 over 6. That's 5/6. So the average rate of change between 3 and 9 is 5/6. For part B, we find the average rate of change between 9 and 12. So that's just between those two numbers. So in that case, my average rate of change would be f of 12 minus f of 9 all over 12 minus 9. So f of 12 is 8, f of 9 is 10 over 12 minus 9 is 3. That's negative 2/3. So the average rate of change on that interval is negative 2/3. But the average rate of change the first time when I was going from 3 to 9, that was positive 5/6. So the first interval had a positive rate of change. The second interval has a negative rate of change. The thing about a rate of change is it's never the same unless it's a straight line. If these dots were in a straight line, then they would be, it would have a consistent rate of change. But these don't. These follow a different function, and so they're going to have different rates of change depending on your interval. So let's go 3 to 15, which would be the entire interval that we've got. So the average rate of change over the entire interval. So f of 15 minus f of 3 over 15 minus 3. So f of 15 is 5. F of 3 is also 5 over the 12, so I get 0 over 12, which is 0. That means the average rate of change over the whole interval was 0. So that's why it makes things hard to predict. Because if you just looked at 3 to 9, you said, oh, that's a positive rate of change, so this data must be going up all the time. But if you look at 9 and 10, or 9 to 12, that data is going down. And if you looked from 3 to 15, there was no change at all. It stayed the same. So what's the right rate of change to use to predict what's going to happen in the future? Will it go up? Will it go down? Will it stay the same? That's why statistics is so dangerous. Because some people could look at certain statistics and make it look like it's only going up. Other people could look at different statistics and say, oh no, it's going down. And then still other people could look at a different interval of statistics and say, but look, there's no change at all. So you have to be real savvy when you're understanding, well, what interval am I looking at? What's the big picture here? And usually the result is, I need more information, right? I need more data to be able to tell what a true rate of change would be. So we're going to continue talking about rates of change tomorrow in class, but I want you to get started working on the average rate of change for your homework. All right, I will see you tomorrow morning.